So this mini lecture is about the kinematic equation without time. This is the fourth kinematic equation. All the kinematic equations up to this point in time, the first three, have time in them. And it's sometimes, actually quite often, useful to be able to solve situations where time is not a given. So, towards that end, let's write down two of our kinematic equation. One, x of t is equal to x naught plus v naught xt plus 1/2 a sub x t squared. And that's the equation for position as a function of time. And then a second equation with velocity. V of t is equal to v naught plus a sub x times t. Okay, so I can use the second equation here to solve for t, and that would be this expression. Let me add a little x subscript over on the other equation here. T is equal to v minus v naught x over a naught x. And so the big idea here is we're going to solve this equation for t, substitute that into here, and we'll get an equation that does not have t in it. This first equation we can rewrite as x minus x naught is equal to v naught x t plus 1/2 a sub x t squared. And so if I take this equation right here and rewrite the left-hand side, but now wherever t appears on the right-hand side, I'm going to make this substitution. So I'm going to get t x minus x naught is equal to v naught x times, okay, so instead of t I'm going to write v minus v naught x over a sub x plus 1/2 a sub x v sub x minus v naught x over ax squared. So we have a t squared here corresponding to this squared, and this substitution is just a linear term. Okay, so if we multiply this equation through by 2ax, then on the left side we will get 2ax times x minus x naught. And then on the right side we'll get 2 v naught x. This a sub x will cancel that out, and so we'll have another vx minus v naught x plus this 2 cancels this. Ax times ax is ax squared, so that cancels the ax squared in the denominator here. And basically I just have a vx plus v naught x squared. Let's see, correction. It should be a minus sign, like that. Okay, so if we distribute these terms here, I'm going to get 2 v naught x times v sub x, this times this, minus 2 v naught x squared, this times this, plus this squared, and this is going to be Vx squared minus 2 V naught x Vx plus V naught x squared. Okay, so first of all, you can see that this term and this term are going to cancel each other. So I can cancel these two guys out. Secondly, I can combine these two. They're both V naught x squared. And so if I do that, I get Vx squared minus V naught x squared. And so here's what I have so far. So the last step is simply to add V naught x squared to both sides. And I'm going to rewrite the equation as Vx squared is equal to Vx naught squared plus 2 ax, a sub x times x minus x naught, which can also be written as Vx naught squared plus 2 a sub x times delta x. So this delta x term is the displacement. So let's put a box around this because it is the fourth kinematic equation for constant acceleration.